Okay. So today what we are going to start is the basics of structural analysis. That means we will be going through the beams and all. Okay. So do you know what is a beam? Do you all know what is a beam? Do you all know what is a beam?
Yes, sir.
Tell me.
Yes, sir.
Tell
The
me.
member which applied by traverse load,
Which?
which apply transverse load, where we apply transverse load.
Give me a simpler definition. Apart from that.
Sir, it is a horizontal structure.
Horizontal what?
Sir, it is a horizontal structure to support the load.
Okay. Anyone else who can cooperate with add to it?
Transfer the load
What
to the
transfer the load?
column beam
So tell
from
me what
the
is the column then?
horizontal structure.
ऐसा नहीं थोड़ा अच्छी तरह बनाओ बोलो. Yeah, someone. So what is a beam actually? Beam is basically a horizontal member which is a load bearing member or which is allowed to transfer the load as we have said. But then the beam is the horizontal. Many people get confused with beams and columns. Okay. So basically beam is what? The horizontal. Now if you say me one thing, what is a column? Tell me that. So what is a column?
It is a vertical structural member.
Which transfer the load to the
To the what?
ground.
Not ground. To the what? नीचे क्या रहता है? Column के नीचे क्या रहता है?
Substructure.
So yeah, in substructure only what is present? Can anyone say?
Footing, sir.
Footing or foundation. So that is what is called actually the basic structure. Okay. Now in a beam, okay. So in a beam, first of all, we'll go one by one. So in a beam, what is happening? The beam is in the horizontal part of the structure, right? Now, if the beam is in the horizontal part, then the beam will be having certain types of loads. Yes or no? The beam will be having certain types of loads. Yes or no? Tell me. Yes or no? The beam will be having certain
Yes, sir. Yes.
types of loads or not?
Yes.
So, can anyone say me what are the different types of load? If you know, if you don't know, we'll discuss it. Definitely, we'll discuss it. But can anyone say what are the types of loads that are being applied on a beam?
Dead load.
Uh-huh.
Live load.
Dead load, live load.
Point load.
Then
Uniformly varying load, uniformly distributed.
Yeah,
Self load.
dead load, live load, these are the two main. Okay, so now on dead load and on live load. So can you tell me what is the difference between dead load and live load? First of
Dead load means that like we have a table and then like we have a bed in the room.
all, and live,
On daily basis, like human being maybe.
yeah.
That is the
And, okay, good, very good. So basically, in dead load and live load, that is the difference. I hope this is clear for you. I hope this is clear for you. This dead load and live load thing. Is it clear or not?
Yes, sir.
yes, sir. It's
Okay.
clear.
So now, give me a minute, okay? Okay, I got it. So, can you see my screen? Let us clear the concept first using a video. Then we'll be going in a bit details. Can you see my screen?
Yes,
Yes.
yes. Now.
No, sir.
हेलो फ्रेंड्स, वेलकम टू माय चैनल पायलट क्यूपी। आज हम बात करेंगे बीम पर लगने वाले विभिन्न प्रकार के लोड्स के बारे में। बीम पर
Is Hindi okay with you? This is in Hindi, I guess. Is it okay? It is. Is it okay for all of you? I'll explain it again. Don't worry. I hope
Yes,
it's
sir.
okay. Okay, fine.
कौन कौन से लोड लगते हैं, तो उसमें से पहला हमारा लोड है पॉइंट लोड और कंसंट्रेटेड लोड, इसको बोलते हैं बिंदु भार। A load which is assumed to be acting at a single point on a beam is called point load or concentrated load. Unit of point load is Newton, kilonewton or ton। पहले हम ये बात कर लें, यहाँ पे लिखा है assume। assume मतलब इसको हम assume करते हैं, वास्तव में कोई विभार बिंदु भार नहीं होता। जिन भार को हम धरन के एक बिंदु पर क्रिया करते हुए माना जा सके उन्हें हम कहते हैं पॉइंट लोड। ये हमारा कोई बीम है, इससे हमारी 3 लोड लग रहे हैं, 3 लोड लग रहे हैं, W1, W2, W3। ये कहलाते हैं हमारे पॉइंट लोड। हमारे नेक्स्ट लोड है यूडीएल, जिसको कहते हैं यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड। यूडीएल इज डिस्ट्रीब्यूटेड यूनिफॉर्मली ओवर द इंटायर लेंथ और पार्ट ऑफ लेंथ ऑफ बीम। यूनिट ऑफ यूडीएल इज किलोन्यूटन पर मीटर और टन पर मीटर। इस प्रकार का भार धरन के कुछ या कोरी लंबाई पर समान रूप से बटा हुआ होता है। इसका जो मात्रक होता है वो किलोमीटर पर मीटर या टन पर मीटर में होता है। देखते हैं क्या है, ये कोई लोड है और ये हमारे जो यूडीएल, ये समान रूप से बटे हुए भार है, इसको हम कहते हैं यूडीएल लोड, यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड। इनको हम जिनका जो यूनिट होता है W किलोमीटर पर मीटर। मान लेते हैं इस बीम का टोटल लेंथ है L, तो इसको पहले हम पॉइंट लोड में कन्वर्ट करते हैं। W और इसके टोटल लेंथ से मल्टीपल कर देते हैं तो ये WL मतलब ये टोटल लोड हो जाता है। और ये जो ऐड करता है ये टोटल लेंथ के हाफ पे मतलब L/2 पे ऐड करता है। पहले तो हम इसको पॉइंट लोड में बदलेंगे W into L, तब और जो पॉइंट लोड बदलेगा इतना टोटल लेंथ है उसके मिड में ऐड करता है। इसको हम इस तरह भी दिखा सकते हैं, कहीं कहीं पे फिगर में इस तरह दिखाया होता है, तो ये भी हमारा यूडीएल लोड ही होता है। और अगला लोड है हमारा यूवीएल, यूनिफॉर्मली वेरिंग लोड। UVL varies uniformly over the entire length or part of length of beam. Unit of UDL is kilonewton per meter or ton per meter। ये धरन के कुछ या पूर्ण लंबाई पर समान रूप से नहीं लगते, बल्कि इनका मान प्रत्येक बिंदु पर बदलता जाता है। इसका मात्रक होता है किलोमीटर पर मीटर और टन पर मीटर। इसको देखते हैं कैसे होता है। ये बीम पर ये है हमारा बीम और इस पे ये लोड लग रहा है, ये क्या हो रहा है कि बढ़ता हुआ लग रहा है, या तो देखते, ये तो इंक्रीजिंग ऑर्डर से है। अगर इसका जस्ट अपोजिट फिगर बनता, ये अगर ये ट्रायंगल इस तरफ होता तो कैसा होता, डिक्रीजिंग ऑर्डर पर। हम इसको कैसे करते हैं, इसका भी मात्रा पहले किलोमीटर पर मीटर और टन पर मीटर होता है। इसको पहले हम टोटल लोड बदलते हैं, जैसे ट्रायंगल का एरिया निकालते हैं 1/2 बेस इंटू हाइट, ये टोटल लोड बदल जाता है। और इसका जो पॉइंट लोड बदल गया, और पॉइंट लोड कहाँ वर्क करेगा, ये अगर इस तरफ से लें तो क्या होता है L/3 पर, अगर ये दिस साइड से लें ये होता है हमारा 2L/3 पर ऐड करता है। इसके अलावा भी कई लोड होते हैं, ये ट्रायंगुलर लोड होता है। दूसरा लोड इस तरह का लगता है, इसको बोलते हैं हम ट्रेपेजोइडल लोड। इसमें क्या होता है, इसमें 2 लोड लगे होते हैं। अगर हम देखें ध्यान से, इसमें 2 लोड लगे होते हैं। एक ये देखिए, यहाँ से हम इसको डिवाइड करते हैं, ये नीचे लग रहा है, ये हमारा क्या है यूडीएल, जैसे हम पीछे पढ़ चुके हैं, और ये ऊपर क्या है यूबीएल। इसमें हमारे 2 लोड लगे होते हैं ट्रेपेजोइडल लोड में। और हमारा अगले है टर्बो लोड। अगला है हमारा मूविंग और रोलिंग लोड। When load varies their place of application, they are termed as moving or rolling load. ये भार समय समय पर अपना स्थान बदलते जाते हैं तो हम कहते हैं मूविंग और रोलिंग लोड। इसको हम हिंदी में कहते हैं चल भार। जैसे हमारे पास है लोड ऑफ ट्रक, बस, ट्रैफिक, ट्रेन और ब्रिज, इन सब में जो लोड लगते हैं वो हमारे क्या होते हैं, मूविंग और रोलिंग लोड कहलाते हैं। जैसे यहाँ पर कोई भी ट्रक हो या बस हो, तो क्या होते हैं, जो लोड होती है वो अपना स्थान बदलती रहती है। इस प्रकार के लोड को हम कहते हैं मूविंग और रोलिंग लोड। अब हमारा वीडियो कैसा लगा कमेंट में जरूर लिखें, और हमारे चैनल को सब्सक्राइब करें। आगे वीडियो देखने के लिए नोटिफिकेशन या बेल आइकन को जरूर दबाएं।
I hope a little bit is clear. I hope a little bit is clear. I hope this is clear a little bit. Can anyone respond? Hello? Are you hearing my voice?
Sir, yes, sir.
Then
Yeah.
is this clear a bit? Okay. Now let me show you one presentation. I hope you can see my slide. I hope you can see my slide.
No,
No, sir.
No?
no. Yes, now we can see.
So now let us go to beams. So what is a beam actually? In strength of materials, the basic thing that you need to know, you have to start with the structural part. Now look, applied and reactive forces. Now forces that act on a body can be divided into two primary types. These are applied and reactive. In common engineering laws, forces that act directly on a structure, these are called applied forces. So which are like, for example, dead load, live load. That means they are acting on the directly on the structure. Now reactive forces are the forces that are generated by the action of one body on another. Now look, if a dead load is acting on a beam or something like that, then there will be what? There will be reactions. Yes or no? If there is reactions, so these reactions will give an, if there is reactions, so these reactions will work. These reactions will show that the Newton's third law is justified because you are applying some force or some load is being applied to a particular structure. Then what happens? After that, that structure gives you an opposite reaction. If that structure gives you an opposite reaction, then definitely this will work. This will be, this will be, what do you call it? This will be justifying the beams, right? So this will be justifying the Newton's third law. Yes or no? So I'm giving you one thing. I'm giving you the link of this presentation in the chat box. Okay, so this will be the link of the presentation. Is it okay? Can you guys just take it from here, or should I need to give you WhatsApp also? Yeah, do I need to give this link in WhatsApp also, or is it okay for here also? Can anyone respond?
So, okay, sir. It's okay. It's okay. So I have already sent in WhatsApp.
Good, good. Okay. Okay. So this is the link of the presentation which I have created. So the applied and reactive force, these are the applied and reactive, not supports. Let us go to the supports. Now look, to hold a beam or a mass or structure, beam is a what? It's a mass or structure, right? Now, so that it can like sustain the weight and everything, we will be needing some supports, right? And these supports are used to what? Connect structures to the ground or other bodies in order to restrict their movements under applied loads, right? And the main purpose of the support is to keep the structure in equilibrium. So in this way, what will happen is that we'll have to apply different types of supports to a structure. What are the different types of supports? Supports are what? Number one is roller support, number two is hinge support, and number three is fixed support. Okay. Now roller support, hinge support, and fixed support. So let us see this type of supports. Now in roller support, what happens is that these are free to rotate and translate along the surface upon which the roller rests. The surface can be horizontal, vertical, or slope. The resulting reaction force is always a single force that is perpendicular to and away from the surface. Now look, this is an example of a roller structure. Okay, this is an example of a roller structure. In this kind of roller structure, what happens is that these are the rollers. These are the rollers. These are the rollers. And the support reaction, that means this will give some reaction, right? Just now as we discussed. So it will be in this direction, maybe in this, okay, it will be in this direction. So for roller supports, there will be only one reaction. Okay, if the roller is in this direction, then it will be here. If it is in this, then it will be like this. Sorry, not this one. Okay. Now we go to the next one. This is a practical example of roller supports. Okay. I hope this is clear for all of you after this. Okay. So these are the reactions, how the reactions on the support should be there for a roller support. Is it clear? Is it clear for all of you?
It's clear.
Yes, sir.
Yes, sir.
The reactions and rollers. What about others? Did they get the link of this presentation so that they can also view? Is it okay for all of you?
Yes, sir.
Okay, fine. Now we go to the next one, which is hinge support. So hinge support. So in a hinge support, it can resist both vertical and horizontal forces, but not a movement. They will allow the structural member to rotate, but not to translate in any direction. Pin or hinge support is used when you need to prevent the structure from moving or restrain its translation. A hinge is a type of bearing that connects two solid objects, typically allowing only a limited angle of rotation between them. Can you give a example of a hinge joint? Can you give an example of a hinge joint? Can you give an example of a hinge joint? Anyone? Can anyone tell me an example of hinge joint?
Sir.
Yes.
Don't know, sir.
Don't know. It's very simple.
Door.
Yeah, who said it? Door?
The door.
Yeah, very good. The door is a very good example of hinge joint. So in a door, what will happen? The door can rotate, right? So this is how it will be. Now, if you go to the next slide, you can see the hinge joint is donated. I mean, denoted like this. Okay, the hinge joint is denoted like this. Now, if this is denoted like this, then what will happen? It will have two reactions. Remember, in roller we have only one. In roller, if it is a roller support, we have only one reaction, right? But in case of a hinge joint, we'll be having two. Okay. The reason behind it is it can resist both vertical and horizontal forces. But in a roller, the roller is what? Roller is capable of moving only in one direction, right? That is why we have that roller. The roller is capable of moving only one direction. That is why only one direction. But in hinge, it is capable of moving the door from one direction to another, right? That is why we are having hinge. Now, this is the example of a hinge. Okay. Or maybe this one. This one, these are all hinges. So this figure denotes the difference between the hinge and a roller. Okay, is it clear for everyone? Is it clear for everyone?
Yes, sir.
Yes, sir.
Good. So now we'll go to the next one. That means the type of supports. Just now we discussed the type of supports. Yes. So in supports, first of all, let us go to the fixed support. That means like this. So in a fixed support, what happens? The fixed support, it will resist both vertical, horizontal, and moment. Now moment means force into perpendicular distance. That is we discussed in the last semester on the engineering mechanics. Now that means what? In a fixed support, what happens is there will be three reactions. That means if you look at this one, this one, this one, and this one. That means it will resist what? Vertical, horizontal, and the moments. It will resist all three parts in a fixed support. Okay, so this is the type of fixed support. Or you can see that in our most cases, if you look at your homes, all our beams are what? Fixed, and they are continuous beams. That means what? The beam is fixed between at the ends in our practical cases or in our homes. Is it okay? Is it okay up to this point?
Necessary, it should be fixed from the both side.
मतलब
मतलब दोनों तरफ से फिक्स होना जरूरी है क्या? ना एक में एक फिक्स हो गया होने से भी हो जाएगा, जैसे कि आपका
different types of beams ना. So if
yeah.
it is dependent on the type of structure. Suppose, I'm telling you, suppose you have only one room. In only one room, the beam is to be fixed. If you don't fix it, that means what? If you don't make it a combined structure with a column and a beam, then what will happen? What will happen? Tell me. If the beam is not fixed, then what will happen? It will not stand like this, right? It will not be stable. Understood?
Yes.
Understood? If the beam now, in certain cases, there may be continuous beams also. Yes or no? Yes or no? Is it clear now?
What, sir?
In certain cases, there might be continuous beams also. Now, in continuous beam, what happens? Suppose you are having multiple rooms. Now, the beam is continuous. That means what? The beam is coming over columns, over different columns. We'll discuss it in the upcoming classes. So these are the different types of way beam is like classified. Is it okay for you, everyone? Is it clear for everyone?
Sir.
Okay.
Yes, sir.